Hi everyone, I am here to present the metric system to you. We will briefly talk about the metric system, what it is, why the US is not using it as its primary system of measurement, and why some of these terms might sound a little bit foreign to you or that you don't have a good reference as to what size we're talking about when we talk about 20 centimeters or 15 liters, and talk a little bit about why that is and also how the metric system is used in science and why it's important to use one system, as well as how to do some basic conversions within the metric system. If you are taking notes in OneNote or even in Google Docs, you might find it helpful to split your screen at this time. That way you can have my presentation rolling at the same time as you are filling in your guided notes. If you would like to take notes on paper, that's perfectly fine. Just please upload a picture of those notes as it will count towards class participation. This video is going to be less than 15 minutes, so I may move rather quickly. If you're filling out the notes, then just pause at any time you need a little extra time to fill in a chart or graph or answer a question. All right, let's get started. So, what are some measurements that you use every day? Think about cooking, describing distances that you're traveling. You can think about your own body. How would you measure your height and your weight? Think about some of those measurements. Type your answer either on the screen or in your notes section, just to get kind of a brief feeling on what are some of the common measurements that you use. So you may have said some things like miles or feet or pounds, maybe a cup of something, and these would all be systems used by measurement in the US. These are customary units, or USCU, United States Customary Units. So units that are commonly used within the US, taught in school, and how we frame of reference communicate to each other the size of things that we're talking about. This system is known as the imperial system, or it's similar to this imperial system based off of it, and it just dealt with random things that were important at the time. So the size of a king's foot or the width of a man's thumb, things that aren't anywhere near being systematically the same or uniform in any regard, but that were thought of to be important at the time and relatively, useful. You could walk off an area using the size of a man's foot or the king's foot, and you would have a general idea of feet, how many feet something was. Okay, so some common US measurements. You might say a ton when talking about vehicles like cars. And if you were to take a ton and divide it by 2,000, you would get a pound. Divide that by 16 and you have an ounce. So 16 ounces in a pound. If you get a 16-ounce bag of cheese, you have a pound of cheese. If you are to run a mile, divide that by 1,760, you'll have 1 yard. Divide that by 3, you have a foot. Divide that by 12, you have an inch. At this point, you're probably realizing that these numbers seem rather random, and that's because they are. There is nothing uniform about this system, and it requires you to remember a lot of hard to remember numbers if you want to move from mile to yard or mile to foot. Making those conversions is not so simple. 1 gallon divided by 4 equals 1 quart, divided by 2 equals a pint, and then from there we go to cup and tablespoon. So these would be measurements of a liquid. And a bushel and a peck. A little less scientifically known. We're not going to be using those types of measurements for dry volume. They're a little bit more arbitrary. Why might these measurements be difficult to work with? So go ahead and brainstorm some things that you see when looking at this table and why it could be a challenge to use these systems of measurement. And I alluded to that a little bit already. So this would be a good time to pause, but I'm going to continue on. And some of you might say things like, it's not easy to convert between the different sizes within a specific type of measurement. So if we're talking about mass, how much something weighs, or if we're talking about the length of something or its volume, how much space it's taking up, then within those different degrees, it's hard to make the conversion. And it's hard to remember, what any of these units really represent. I mean, of course, we know that a foot is 12 inches, so there's a pound is 16 ounces, there's 4 quarts in a gallon. Some of these are pretty common, but you may not know that a mile is a yard is 1/1760th of a mile. So those things are a little bit harder to keep in track of in your memory. So what are some units from the metric system? Can you think of any? And we have this comic to kind of comment on how funny it is that we're still using our system of measurement unique to most of the rest of the world. And here we have a video for a metric system song. And we're just gonna step out of this for a moment and go to YouTube. All right. Okay, so I think we get the idea, and you can certainly watch the rest of that on your own. The link is in the PowerPoint presentation, but for the sake of time and keeping this short and simple as far as the presentation goes, I'm going to move on, but hopefully some of that, watch it multiple times and maybe something sticks or it catches with you. So I would just say that the metric system is the most popular system for the world. Most of the world uses the metric system. It's easy for all scientific work because it is easy to convert between units, and it's because it's based on a decimal system. So each unit is 10 times larger than the next, and this makes it more precise and accurate for measurements smaller than an inch. So in the imperial system, we don't really have a measurement for smaller than an inch, and we of course need to be able to make more precise measurements than that. So it's nice to have centimeters and millimeters in order to do that. So SI units stand for Système International, which is French for international system. Internationally standardized so that there is a common language between nations and different branches of technology. So this would be a universal system. Who doesn't use the metric system? Well, we don't use the metric system, and Liberia and Myanmar, also formerly known as Burma, don't use the metric system either, but they have a more progressive approach to switching over to the metric system, and I believe Myanmar wanted to make it to metric conversion by this year, though I don't know if they have successfully done that yet or not. But they have some form of conversion, just like we do as well. We use it in most scientific applications or when we're working with international manufacturers. And it hasn't always been that we haven't just considered switching over to the metric system. Actually, in 1896, there was a bill that was introduced, and there were, out of the 29 votes, 6 nays, and 4 of those represented large manufacturers. So it was just, even back then, it was considered too much of an expense to make the conversion from the US system to metric. Then it wasn't until President Ford in 1975, he put in a metric conversion act to help with the education of the metric system and to help get businesses and schools on board with switching over to the metric system. And that had some agreement, but you can see that today most of our reference for measurements exists with our imperial or US system. So this is a video that I'll have you watch on your own, and it kind of it talks about what happened to a satellite that we launched through NASA, where units on the ground were different than the units used on the satellite. So because the ground system was using US units and the satellite system was using metric units, it turned out that they made some colossal mistakes with their conversions and the way that the satellite was communicating with the ground, and it basically ended up getting way too close to Mars, and we lost that satellite. So just talks a little bit about why it's important that we all get on board with the same system. So the metric system, you need to know 4 words basically. These would be the base units: meters, grams, liters, and seconds. And I'm about to run out of time on this particular slide or presentation. So the next part would be just going over how to practice these conversions. So these are the base units that would be used in science: meters for height, grams for mass, and liters for volume, and then time is obviously in seconds. So I'm going to go ahead and end this video, and then please watch the next for help with the practice on the guided notes.